Right, okay, so we are looking at unit vectors. It's something you might have seen before, but not necessarily. Okay, so there are three special unit vectors, each for one of the different kind of planes, unit vectors. Okay, so one for the x direction, one for the y direction, and one for the z direction. Okay, so they represent a vector of length 1 in the x, y, and z directions. So this is another way of, like, where we're going to use this is it's another way of like writing out vectors. So instead of writing them as column vectors, that's the one, we can write them in terms of unit vectors. So they've each got a special name, and we have I, which is, I'm going to do this in 3 dimensions, but if we've got 2 dimensions, it's pretty much the same. Okay, so I, which is 1 unit, so 1 box along, if we're talking in terms of like a grid or something, 1 unit, the unit could be a meter, it could be a kilometre, it could be a centimetre, it could be a nanometre, but it's 1 unit, whatever that unit is that they'll tell us, in the x direction. So that's why it's the top one, because our vectors go x, y, z down the way, like coordinates, but down the way instead of across the way. Okay, we have j, which is in the y direction, so that's 0, 1, 0. And our last one is k, so these run alphabetically I, j, k, and k is a unit vector in the z direction. Okay, so if we've got 3 dimensions, that's the ones we have. If you've only got 2 dimensions, you only have I and j. It just means that you knock the z column off your vector. So instead of having 3 numbers, it's just got the top 2. So if we've got a vector, we'll call it u, which is a, b, c. We could say that that's equal to like a times that first one, so a times I, plus b times the second one, plus c times that last vector. So it's like saying there, to get that a value, we can say it's a lots of this vector, like 1, 0, 0, because we multiply it by that scalar, so 1 times a is just a. And then we can add, with adding vectors, we know that we just add all the x's, then all the y's, and all the z's. So no matter what we do here, if we're doing this, it's going to be this lot, and those are still just going to stay zeros. So we've kind of split it up into our x's, our x direction, our y direction, and our z direction. So that's the same as saying we can have a, I, plus b, j, plus c times that unit vector k. Okay, and these unit vectors are always, like, they always have the same size. It's always 1, like I is always 1 in the x direction, j is always 1 in the y direction, and k is always 1 in the z direction. Like the directions, like the letters for the unit vectors never change. They're always constant, okay? Right, so one of the other things we need to know about unit vectors is that if we have a magnitude, like a vector, v, so I'll start a new page for this. Right, so if we've got a vector v, which is just a line like this, we can work out its unit vector by doing 1 over the magnitude of v times that vector v, It's to do with the fact that to make it like, we're just trying to say that it's got a size of 1. Because for any vector, there's a unit vector that exists that's 1 unit long, which is its unit vector. The ones that we were talking about previously are specific ijk unit vectors, that we talk about. They're very specific for the x, y, and z directions. But each vector that exists also has a unit vector that's just in the same direction as it, but has a length of 1. So what we've done to make it, so if it has a length of 2, we need to do 1 over 2 to make it 1 long. So like we find that magnitude and divide by it. So magnitude of it, or the length of it, if you want to talk about it that way. So we have to do 1 over the magnitude of that times by the vector, and that gives us the unit vector that's the same size. So an example of this, right, so if I've got this vector v, which is equal to 5 over 12, right, and we want to find the unit vector in the direction of v. What we're going to have to do is find the magnitude of that vector. Right, so the magnitude of v, this is the thing we should remember from the last one. It's from National 5, it was in the last video. So it's the square root of a, which is 5 squared, plus 12 squared. For these I put them in brackets because you need to be really careful with the negatives and things. Like if there's a negative in the vector, you need to write it in the equation. But you need to make sure that it's exactly correct. So when we do that, we get, in a calculator, we get that it's 13. Okay, so the unit vector is going to be 1/13 of 5, 12, which is equal to 5 over 13 and 12 over 13. Okay, and that works for any vector at all that we can find the unit vector in its direction. Right, okay, so another kind of thing that we can do with this is just changing vectors from being in their component form, column form, even, into being in terms of their unit vectors. So we can get given, say, p is equal to 3 minus 2, and then we can just write that as 3 times I minus 2j. Okay, it is honestly as simple as that for putting vectors into their from their component form or their column form into their unit vector form. Like another example, if I've got 3, 0, 4, right, that's equal to 3i. We've got 3 in our x, we've got nothing in our j, so like in the y, so we've got no j, and then we've got plus 4k. Okay, so that's it. You can like change between the two really quickly and really easily. It's up to you if you want to work through questions using component form or using unit vector form. Like if you're adding two vectors when you've got them in unit vector form. So I'll just kind of put a line down here. Right, so if I've got, say, let's go with p is equal to 2i minus j plus 3k, and I've got q is equal to I minus 3j. It's up to you if you want to leave them like that, or if you want to change them into the column vector form that we've seen more at National 5. But, so if I want to do p plus q, right, what I can do is add, so it's like 2i plus minus j, not plus j, right? Plus 3k. And then we're adding on the second one, so plus I minus 3j. And we can kind of collect the like terms like it's just algebra. So we've got 2i plus another I, so we have 3i. And then we've got minus j minus another 3j, so minus 4j. And then we've got plus 3k, so we have plus 3k. Right? You can do it that way if you want, or you can do it the usual way using the column vectors. Either's okay. And again, just for finding the magnitude of these, so I want to find the magnitude of p plus q. It's the square root, and then use the letters in front of the I, j, and k. So we have 3 squared plus minus 4 squared plus 3 squared. So we get the square root of 34. Okay, so working with unit vectors, all the rules are kind of the same. We still add the x's and the y's and the z's. But this time it's like we add the i's and the j's and the k's. Okay, nothing's really changed. To find the magnitude, still the same. You can change really easily between component form and using the unit vector form, using I, j, and k. Your top of your column vector becomes your x. The second one down becomes your y, which goes to j. Your x goes to I, and your z goes to k. And not forgetting to draw that little line underneath it to denote that it's a vector every time.